Okay, so now we're going to go ahead and finish up that last little bit out of 2.5. And then we'll look at 2.6. And 2.6 is probably the shortest section in this chapter. So let's go ahead and finish up 2.5. And we were talking about, before break, things that were functions. And as long as you could solve it for y, it was a function. Now we're going to look at relations. And those are not functions. And how you find the domain of a relation is you check values. So this is going to be the domain for relations. What you do is you check, well, first thing you need to do is solve it for x. So the domain for relations, what you do is you solve it for x. And then you're going to plug in values, and you're going to see what you get out. So you're going to have to solve it for x, okay, and then you'll check y equals 10, and y equals a negative 10. Now there are three outcomes. If both are positive, then what you have is your domain will then be 0 to infinity. If both are negative, then the domain will be negative infinity to 0. And if one is positive, one of them is negative, then the domain will be negative to positive infinity. So those are the three different outcomes that we have. We have to check two values of y. So we have to solve it for x first. And then we plug in our values of y and we observe the signs. So we'll look at three of these. So here's one that we're going to look at first. Okay, now why would this one not be a function? Well, for it to be a function, I have to be able to solve it for y. I can't solve it for y because it's y to the fourth power. So that power on your y, that makes it then not a function. So it's definitely not a function. Now we know we need to check our values. So it's been solved for x already. So we're going to plug in our values here. And we're going to plug in y equals 10 first. We've got to plug in 10 and negative 10. The textbook has you plug in y and negative y, but I think that's more confusing. I think it's easier if we just plug in values. I think it makes more sense for us. So if I plug in y equals 10, that gives you x equals now 10 to the fourth power, right? Because we're plugging in the y equals 10 then. And if I plug in 10 to the fourth power, well, that's going to be what? 10 to the fourth power, I believe, is 10,000. So that gives you 10,000. I don't care about the number. All I care about is the fact that it is what? What's the sign on that? Positive. Now if I plug in a negative 10 for the value of y again, if I plug in a negative 10, let's remember our order of operations. We'll do that power first with the parentheses. And what happens if that negative 10 is inside the parentheses? Well, negative 10 to the fourth power, would that be positive or negative? Well, let's check and see. Negative 10th to the fourth power. That's negative 10, negative 10, negative 10, and negative 10, right? And 4 negatives are going to make that then again what? Positive 10,000. That is also positive. Now, if both of them are positive, what do we know? We know then that both are positive. So then the domain would be 0 to positive infinity, because I'm only getting out positive values. Now we're barely touching domain and ranges in this class. In college algebra, you do a little bit more. In calculus, then you look at all different kinds of functions in the domains and the ranges. So we're just looking at just scratching the surface. In a calculus course, and also a little bit in college algebra, you go into a lot more in depth. So it's not a function, and my domain would be 0 to positive infinity. The next one is going to be the opposite. The next one is x equals minus y to the second power. So this one's the same, but yet your answers are going to be different. First off, is this a function? Just like the last one, it's clearly not a function. Why is it not a function? Square on that y. If it was on the x, that would be okay. But since it's on the y, it makes it not a function. Now, since it's not a function, then we have to check values for our domain. So we're going to check y equals 10. And if it makes it easier to keep track of things, you could put a parentheses around that 10, just so you don't make a mistake with that negative. Notice that negative's in front of the parentheses. Okay, so 10 squared. What's 10 squared? 100, and what's in front of it still? So we just bring that negative down. So that would make that one negative. What about y equaling a negative 10? Well, if I plug in a negative 10, that gives you x equals minus a minus 10 squared. Resist the urge to cancel those signs. Why can I not cancel the double negatives? Well, order of operations, what do I have to do first? Parentheses always go first, right? Okay, so we do that parentheses. Now, that negative 10 is inside the parentheses. So what happens when I square a negative 10? When you square a negative number, it becomes what? Positive 100, but what's still along with it now? Negative. So this case is also negative. So what do I know? Unlike the last one, they were both positive. In this case, they are both negative. And so what would my domain then be? we only get out negative values and 0. So my domain would be negative infinity to 0. And again, we're barely touching the surface on domain and ranges. This is just an introduction to them. They can get really complicated in a calculus course. Not so much in college algebra either, but in a calculus course, when you look at domain and ranges of different functions, it becomes kind of tricky. This class, we're barely touching the surface. College algebra, you go into a little bit more detail. Let's look at one more of these that's not a function. Okay, so this one again is not a function. Now, what makes it not a function? We kind of talked about it a little bit in our definition, but it's not a function because of that inequality. So because of that inequality, it's not a function. So because of that inequality, that tells me that it's not a function. And the reason for that is the shading. Remember, when we graphed inequalities, we had to shade them. And when you shade something, it breaks the vertical line test. So this is not a function because of the inequality. Now, the others have been already solved for x. This one is not, so we're going to solve it for x. So x minus y equals 2. We'll move that we'll move that y over. My mistake there. I went the wrong one. Move that y over. And that gives you x equals now y plus 2. So for domains, when it's not a function, we have to do something a little bit different than we're used to doing. We solve it for x because it has to be x equals. Now we're going to plug in our values of y. And I didn't even give you one of these in your homework, but I think it's good to know for college algebra. So let's plug in our values. Let's plug in 10. And that's 10 plus 2, and so that gives you x equals 12. And that is positive, right? So we plugged in and we checked x equaling 10. Yeah, you can use any number you want. 10 is just easy to work with. You don't want to use a really small number because that 2 might overpower it. So I always just pick 10. 10 will work for what we need in this class. Now, in like a calculus course, you'd have to plug in y and negative y. But I think that's too confusing for us in this class, so we just use 10 and negative 10. But the textbook has you plug in y and negative y, but again, I think that's more confusing. So we're just going to use 10 and negative 10. Now, if I plug in negative 10, what's going to happen? Well, that gives you x equals now minus 10 plus 2, and x equals a negative 8. Now, this is, again, one of the three choices that we had. When it was positive, what was it? When both were positive, it was 0 to positive infinity. When both were negative, it was negative infinity to 0, right? Because that's only the negative half. When you get out both positive and negative, what was it? Both positive and negative, one positive, one negative. Your domain was then everything, because you can get out positive and negative numbers, so your domain was negative to positive infinity. And I didn't even put one of these in your homework, but I think it's kind of important to make sure you see them now, so you'll see it again in college algebra and it'll make more sense. We do the exact same problems in college algebra, except we add on the range, which is a whole different different part. But in this class, we only do the domain. College algebra, you do the same type of problems, but you have to do the domain plus the range. That should now finish up 2-5. And there's only one of these that's not a function, and I can tell you right now that that's question 13. So question 13 is the only one that's not a function. That's it. All the others are. So next we're going to look at 2.6. And in 2.6, we're going to be looking at function notation. Now, what a function does, and you'll cover this, again, more in college algebra and a lot more in depth, but a function takes something and changes it to something else. And we use functions all the time. Whenever you go to the gas station, okay, you pay for gasoline, right? What do you get out? Gallons of gasoline. That's a function. Money gives you something else out. When you go to work, you work so many hours. What do you get out? A paycheck, right? Functions are used everywhere. You work so many hours, you get so much pay. That's a function. This is called function notation. So this is said f of x and this is function notation. F of 3, how would you say f of 3? Well, that would be said f of 3. And you could even have a different function than f. It could be, let's say, an h. So h of 4. How would you say h of 4? Well, h of 4 would just be simply said again, h of 4. So that's how you say them. So if I say f of x, that's, in English, that means f of x. You just put whatever function is out front, whatever letter it is, and then if it's a number, it's a number at the end. If it's a variable, it's a variable. So f of x is just said f of x. And f of 3 is f of 3, just to make sure we know how to say them correctly. That's all it is. And these are all examples of function notation. We're going to go ahead now and plug in values into these functions. So I'm going to give you a function, and you're going to plug in the value that I give you. So let's say you're given f of x equals 5x minus 3, and I want you to find f of 4. It's very, very easy to do. What we do is we replace. So see that 4, that replaces the x. So what would f of 4 be? If I take my original function up here and I replace that x with a 4, well, that would be 5 times 4 minus 3. And 5 times 4 is a 20, and 20 minus 3 is a 17. So in this case, f of 4 would be what? Would simply be 17. You just plug in that value for x. Whatever you got, you just plug it in. That's it. We'll look at another one. And then we'll look at one that has fractions. And then we'll look at plugging in different variables. And it doesn't necessarily have to be an f. It can be a g. It can be a k. It can be an h. Let's try, how about h of x equals minus 3 x squared plus 2x minus 4. And I want you to find h of a minus 3. So don't try to make these more difficult than what they need to be. What are we doing here? All we are doing is we're taking that x and we're going to replace that x everywhere now with what value? Negative 3, right? So here's what you need to remember on these. If there's an x inside the parentheses, then I get an answer out that contains an x. If there's a number inside the parentheses, like this one, what am I going to get out? I'm going to eventually get out a numbered answer. So variable, variable answer. Number, number answer, just like this one. And you plugged in that 4, it gave you the number 17. Let's rewrite this one now with our number. So we replaced that x now with what? We replaced that x with a negative 3. Watch your order of operations and be careful when you evaluate this one down. So h of negative 3. Well, first thing we're going to do is negative 3 squared. What's negative 3 squared? Negative 3 squared is a positive 9. So that comes down. And we can go ahead and multiply here as well. Okay, 2 times a negative 3. 2 times a negative 3 would make that a negative 6 and a minus 4. Negative 3 times 9 is a negative 27. And we've got a minus 6 and a minus 4. And when I combine all of those together, it looks like I've got a minus 37, I believe. It's 27, 6, and 4. All of them are negative, so it would be a negative 37. So h of negative 3 would be what? Negative 37. All I did was replace that x value with, in this case, that negative 3. It can also be done with fractions. So let's do one of these with fractions, and then we'll look at how to use variables. So let's say you're given f of x to be 4x squared minus 2x plus 1. And I want you to find f of a negative 1/3. Now this one is a little bit more complicated just because of the fractions. There's only one of these in your homework, and that's your first question. So you're going to be plugging the values in. We're going to then combine the fractions together, and we're going to simplify them down. So you're given that original equation, or the original function there, and I want you to find f of a third. So what are we going to do? We're going to replace that x everywhere with what? With a third. So that's all I did. Now, how do we square fractions? Well, if we forgot how to square a fraction, we just simply write it out and multiply. So 1/3 quantity squared would be a third times a third, which is then 1/9. And you can combine things together before, or you can just do it in the next step. So all I did there, and I just want to break it up into an extra step because I don't want us to get confused. Sometimes it's easy to see what we're doing now, but when you get home, you might have missed a step. So I'm not going to skip any steps here. Order of operations. Exponent goes first. So we did that exponent. Now we can multiply. Okay, and that's like a 4 over 1. 4 over 1. So that's 4 times 1. That makes it a 4. 1 times 9. That makes it a 9. Next one. Minus 2 times 1. That's a minus 2. 1 times 3. That makes it a 3. Now for this problem, we don't have an equal sign, so we can't really clear out the fractions. So we're just going to have to work with the fractions. So we can't really clear them out. We're just going to work with them. So my least common denominator again is going to be a 9. So this one's going to need a 3 over 3. This one needs a 9 over 9. We can't clear them out because we don't have a left-hand side to work with. So we have to use common denominators here. That way we can just put them together. And now we've got 4 ninths minus 2 times 3 is a 6. 3 times 3 is a 9. And then we've got 1 times 9, that's 9 over 9. Now what do we notice here? Okay, we've got all common denominators of a 9. So we can put them all together. And we've got now 4 minus 6, that's a minus 2. Minus 2 plus 9 makes it 7 ninths. So you just combine them together because they all have the same denominators. And so what's my final answer? Well, f of 1/3 now equals what? F of 1/3 equals that 7 ninths. And there's only one question like this, and that's question 1. We can also rewrite equations into functions. So for the next ones, what we're going to be doing is we're going to be solving for y, and we're going to replace y with the function notation f of x. So solve for y, and replace y with f of x. So we're going to solve it for y, and we're going to replace y with that f of x. Because y and f of x can be used interchangeably. So y and f of x are the same. Once we get these done, then we'll look at how to graph them. And then we'll look at how to work with functions where I have you change the variable. So we only got a couple more things to cover in this section. So solve for y and replace y with f of x. And this goes with homework questions 2 and 3. So this is going to be like homework questions 2 and 3. So the directions are going to be solve for y and replace y with that f of x. That's it. We're not plugging in values. All we're doing is solving it for y. So we want to do that. So move that 4x over. So we've got to solve it for y. And that leaves you then with y equals now a minus 4x plus 9. Right? Nothing new. We've done this many, many times before. The only new step that we need to do is once we have solved it for y, we can replace y with that function notation f of x. So we solved it for y, And then we just simply replace that y with f of x, and that's it. That's all you need to do for those two questions. We'll look at one more of these just to make sure we have this concept down. Then we'll graph. And then at the very end, we'll plug in values, or variables in. Let's do one more of these. Again, same directions. Solve for y. And replace y with f of x. So, well, let's put a 7 in front of that y too. That way you have to divide as well. So we'll put that 7 there. So 7y minus 4x squared equals 12. Now, what do our directions say? Solve it for y. So go ahead and add that 4x squared over. And now we've got 7y equals 4x squared plus 12. We'll divide by our 7. And that gives us y equals 4/7 x squared plus 12/7. And what's our last and final step? What do? We replace y with what? F of x. So it's x squared plus 12/7. Okay. Now let's look at how to graph these. We're going to be graphing these the same way we would graph lines. Nothing new. We're going to graph and also find the domain and range. And we'll use an h of x here. So let's say h of x equals 4x plus 3. Okay, well, what do we know? We know that that function notation is the same as y. So I can actually replace that h of x with y. Now we should know what to do, because that function notation is the same as your y. They can be used interchangeably. Function notation and y are equivalent. Sometimes one might be easier to use than the other. Now, what are we going to do? Well, this is in slope-intercept form. So my m in this case is a 4. And my y-intercept would be what? My y-intercept would simply be 0, 3. Nothing new. How would you graph it? We've got our y-intercept at 3. And what's my slope? 4 over 1. So what are we going to do? Up 4, and then what? Over 1. So start at your 3, and you're going to go up 4. So 1, 2, 3, 4. You're going to go up 4, and then you're going to go over 1. Connect them together, and there's your graph. What's my domain and range going to be? We've covered this before, in the last section before break. But on all of these lines, your domain and range are going to be the same. And does anyone want to take a guess as to what that domain and range would be? You're looking at my line there. What about the domain? Does it go up to the right? Yep. Does it go down to the left? Yes. It goes to the left. It goes to the right. So your domain would be negative to positive infinity. What about your range? Does it go up? Yep. Does it go down as well? Yep. So your range is also negative to positive infinity. All of these lines are going to have the same domain and range. And that's always going to be negative to positive infinity for these. We're not going to look at any vertical or horizontal lines. One more. Same direction. Let's try and graph and find the domain and range. And let's use, we used h of x before, let's use f of x. So there's our function. What do we know about that f of x? Well, that f of x is going to be the same as y. Just as kind of a reminder, that 1/3, that is your slope. And what about the y-intercept? Well, is there any number on the end? No, there's no number on the end, is there? Right? So if there's no number on the end, what is that like? It's like having plus 0, isn't it? So my y-intercept would be what? 0, 0. Remember, there's no number on the end. Your y-intercept is 0, 0. So we started our 0, 0. Now my slope is 1/3. So what do? Up 1 over 3. So from that 0, 0, you go up 1. And then you go over 1, 2, 3 units. Make your dot, connect them together. And what about your domain and your range again? They're always the same for these. And the domain and range are both, what, does anyone remember what they would be? Yep, negative to positive infinity for both. Now we do have one more quick thing to look at, and that's how to plug in variables into these functions. And we can change the variable into a different one. So I'm going to give you a function, just like we did a moment ago, and instead of plugging in a number, you're going to plug in a different variable. So let's say you're given f of x equals 3x minus 2. And how about I have you find f of z? Now we do the same process that we would have done with numbers. If that would have been f of 3, we would plug in the 3, right? But we don't have a 3 now. We don't have a number. We have a z. So what do we replace that x now with? Z. So when I rewrite f of z, what would f of z be? F of z would be 3z minus 2. All I did there was replace that x with a different variable. That was it. Okay? Plugged in the different variable. You can also plug in a variable plus a number or minus a number. So let's see, you're given f of x to be 4x plus 5. And I want you to find now f of a minus 3. Okay, so how would we do this one? Well, instead of having the x, what are we going to replace the x with? An a minus 3, right? That's what's inside the parentheses. So let's rewrite it as 4 times a minus 3 plus 5. We just replaced that x, in this case, with the a minus 5. Or sorry, a minus 3, minus 3. Now, what do we do with that 4 out in front? We need to combine this together. So we're going to distribute that 4 through. And that leaves you with 4a minus 12 plus 5. And combine. And that is now 4a minus 7. And that is f of a minus 3. So we just replaced that x with whatever's inside the parentheses. We'll do one more, and this one we've got a FOIL. So we'll remember what foiling is here in just a moment. So let's try one more where we have to FOIL in this case. So you're given f of x to be 2x squared plus 3x minus 1. And I want you to find, and I'll use the same numbers they use in the homework here, how about f of k minus 1? So this is what you're given for your function. I want you to find f of k minus 1. We need to write it with parentheses, just like the last one. So the 2 comes down, and what do we replace that x with now? What's going to go inside the parentheses here? Yep, k minus 1, and that's going to be quantity squared. And then we have 3. We replace that x with what now? K minus 1. So this is what we've got. We need to break it down a bit. And this is going to be covered a lot more in detail in the next chapter, because we're going to learn how to FOIL here. Okay, so we're just going to work with that k minus 1 quantity squared. We have to write it out as k minus 1, k minus 1. And then we're going to have to FOIL. Now, how do we FOIL? Hopefully you kind of remember how to FOIL. If not, it's pretty easy. Okay, to FOIL. To FOIL, we take the first times the first. That's what the F stands for. First times the first. So you just draw your arrows. So, first times the first. That's k times k, and that's k squared. Then we take the outside times the outside. So that's k times a minus 1. So that's a minus k. Then we do the inside times the inside here. Negative 1 times k, that makes that a minus k. And then finally we do the last times the last. And the last times the last is minus 1 times minus 1. that makes that then a plus 1. These k's can go together here, and that gives you then k squared minus 2k plus 1. So that gets replaced there. So all I did was I FOIL, and I FOILed that out to the side, and then I combined like terms, and now we can finish it. So we FOILed it out, and there's only one of these in your homework. We FOILed it out. Now we can distribute that 2 through, and distribute that 3 through, so we can see what we we're working with here. So distribute that 2 through, and that's 2k squared minus 4k plus 2. Distribute the 3 through, we get 3k minus 3, and then on the end is a minus 1. So all I did was distribute that 2 through, and distribute that 3 through. Now we can combine. Always write the highest power first, so that's 2k squared. Then we can look at the k's. How many k's do we have? We have minus 4 and 3. So minus 4 plus 3. That makes it a minus k. And now we do the numbers at the end. So what do we have for our numbers? We have a 2, a minus 3, and a minus 1. So 2 minus 3 is a minus 1. Minus another 1 makes it a minus 2, doesn't it? And that's your final answer. And that is f of k minus 1. And that would be your final answer there. And that's the last problem that we're going to look at. Now, you may have questions on number 6. That's just plugging values in. So question 6 in your homework, they give you an equation, you just plug in the value. And we didn't really have enough time to cover that one. We can work it through next time in your homework if we need to. But question 6 is just plugging a number in. So what's our homework? Well, our homework is 2, 5. You should be able to do them all. 2, 6. You should be able to do them all. And then you should be able to do that practice exam. And our exam is next week. Just so we remember, what can we have on our exam? You can have a page of notes or note cards. So 1 page of notes or note cards. And that can be front and back. Or note cards. And then you'll also need to bring a calculator. I'll be posting that worked out answer key for your practice exam when I post the notes as well. I've already got it worked out. I'll post that on Blackboard, so you'll get an email just like I do with all the notes and everything else. So check in Blackboard or check your email and you'll get that practice exam answer key. So that's what we're going to be doing next week. We'll spend the first part of next week working on that practice exam, going over questions if we need to, and then we'll spend the balance of the time working on your exam. I'll probably put in 2 extra questions, so you'll be able to skip 2 of them. So you probably have 22 questions, you'll be able to skip 2. So I will see everyone next week then.